Okay, here we are with our last lesson in Unit 5, Volume of a Sphere. The materials you're going to need for this is a calculator to help speed up your calculations. And let's start with our discussion. Here are some pictures of spheres. You have a basketball, a billiard ball, it looks like a rubber bouncy ball, and just a net of a sphere. Come up with a mathematical definition of your own that describes what a sphere is. All right. Finally, we come to the volume of the sphere of radius r. First, recall that a sphere of radius r is the set of all the points in a three-dimensional space of distance r from a fixed point, called the center of the sphere. So a sphere is, by definition, a surface or a two-dimensional object. When we talk about the volume of a sphere, we mean the volume of a solid inside this surface. The discovery of this formula was a major event in ancient mathematics. The first person to discover the formula was Archimedes, but it was also independently discovered in China by Zhu Shangxi and his son Zhu Gang by essentially the same method. This method has come to be known as Cavalieri's principle. Cavalieri was one of the forerunners of calculus, and he announced the method at the time when he had an audience. So here's a demonstration to help us come up with the volume of a sphere. So basically, the sphere is the same height as the cylinder and also has the same diameter. If you notice the marks on the cylinder, you'll notice that the cylinder has been partitioned into 3 equal parts. Now notice how much water has filled the cylinder. So basically, based on the demonstration or video, we can say that the volume of a sphere is 2/3 the volume of a cylinder with the same diameter and height of the sphere. So essentially, if the radius of the sphere is the same as the radius of the base of the cylinder, and the 2r, 2 times the radius, indicates the height from top to bottom of the cylinder and also the sphere. The derivation of this formula and its understanding requires advanced mathematics, so we will not derive it at this time. All right, go ahead and complete exercises 1 through 3 on your lesson worksheet to derive the formula for the volume of a sphere. Check your work as you go by continuing the video. All right, you should be done with exercise 1. Notice when we get to exercise 3, if the volume of the sphere is 2/3 the volume of a cylinder with the same diameter and height, what is the formula for the volume of a sphere? So if the volume of a sphere is 2/3 the volume of the cylinder volume is pi r squared times the height. Well, if the height is the same as 2 times the radius, we substitute 2 times the radius in for height, because the 2 times the radius is the height of the sphere. Well, now simplifying this, that means if we use multiplication commutative property, we can move the 2 close to the 2/3, and this becomes pi r squared times r, which becomes r to the 3rd power. And 2 times 2/3 is equal to 4/3. So the volume of a sphere is 4/3 times pi times the radius cubed. So let's take a look at example 1. When working with circular 2- and 3-dimensional figures, we can express our answers in 2 ways. One is exact and will contain the symbol for pi. The other is an approximation, which usually uses 3.14 for pi. Unless noted otherwise, we will have exact answers that contain the pi symbol. For examples 1 and 2, use the formula from exercise 3 to compute the exact volume for the sphere shown. So here we have a sphere of 4 centimeters, or with a radius of 4 centimeters. So if the radius is 4 centimeters, then that would be 4 to the 3rd power, which is 64. 64 times 4/3 times pi is 256/3 times pi, which can be written as a mixed number, 85 1/3 pi. So the volume of the sphere is 85 1/3 pi cubic centimeters. Example 2. Let's take a look at it. What is the radius of the base of the cylinder? I'm not going to copy the question for example 2, so you're going to have to refer to your lesson worksheet. The radius of the base of the cylinder is 8 inches. Could the sphere have a radius of 8 inches? No. If the sphere had a radius of 8 inches, then it would not fit into the cylinder because the height is only 14 inches. With a radius of 8 inches, the sphere would have to have a height of 2 times r, or 16 inches. Since the cylinder is only 14 inches high, the radius of the sphere cannot be 8 inches. What size radius for the sphere would fit into the cylinder? A radius of 7 inches would fit into the cylinder because 2 times r is 14, which means the sphere would touch the top and the bottom of the cylinder. A radius of 7 means that the radius of the sphere would not touch the sides of the cylinder, but it would fit into it. Now that we have the radius of the largest sphere is 7 inches, what is the volume of the sphere? Well, substituting 7 in for the radius, 7 to the 3rd power is 343. Times 4/3 is 1,372/3 times pi, which is 457 1/3 pi. So the volume of the sphere is 457 1/3 pi cubic centimeters. All right, go ahead and try exercises 4 through 8. Complete those exercises, checking your work as you go by continuing the video. Okay, here are the answers. All right, let's wrap this up. We know the volume formula for a sphere with relation to a right circular cylinder. We know the volume formula for a hemisphere. And we can apply the volume of a sphere to solve mathematical problems. See you in class.